All right, we're gonna look at some easy oxidations. Really, really simple. I'm looking at GSS Monday, 9/30, 2019 practice sheet. All right, so let's do a little PCC. This is an oxidizer, weak oxidizer. So the way I do it is you have to remember to count your carbons. You can't lose or gain carbons. You never do that when you're doing this oxidation thing. So you see your carbon here, and then it's connected to an OH. That carbon doesn't go anywhere. It stays there. So let's just draw a dot. PCC is going to oxidize. And what that means is, what it means by a weak oxidizer is that it's going to go to an aldehyde. So basically what we did effectively was we basically put a double bond in here and added an H. It's not really great to think of it like that. So first of all, let's look at, the progression of oxidation. So you got just a carbon here. You got 1, 2 carbons. That's ethane. Your next stage of oxidation would be the alcohol. Remember, we're not losing or gaining carbons. 1, 2, 1, 2. The next stage would be our aldehyde. And the next stage would be our carboxylic acid, all right? So if it helps you to actually kind of see it in the initial stages, think of it like this. So you got your alcohol, right? Okay, that part's pretty simple. Now, how do you figure out the way to see going from here to the aldehyde? You could do it like this. A lot of students like to draw it like that. To me, that looks strange, but I used to draw it like that to see kind of the way these bonds go. Helps you figure it out. Same with the carboxylic acid. Basically, all you're doing now is just adding an OH there. It's all the same thing, just drawn out in a way that might make it more easy to understand. This is all about really breaking this down to kindergarten level. Say we have our ethane. Now let's draw this up like that. This is where you're getting into my tricks. These are my tricks. So this is all the same exact thing. I'm just showing it in different ways so that different brains can understand what's going on here. I want to break this down into simple terms. So now how do we go from here? Because you just have to, first of all, you have to memorize that you go to here, then you go to the alcohol, then the aldehyde, then the carboxylic acid. That's only a couple stages, so it's not hard to remember all that. So from here now, how do you imagine the aldehyde? You just basically add your double bond, take away the H. That's the aldehyde. Now, for the carboxylic acid, just add an O in there. Boom, you're done. For a long time, I actually drew it up like this. It looks funny, but until I got to the point, because first of all, it's really hard to draw up like that. It's not conducive to handwriting. It's easier just to go down. You'll get used to what works best for you. But I just wanted to explain this in extreme detail so that you kind of understand what's going on. Okay, so feel free to orient this crap however you want. If you wanted to write the OH for example, like this, you could do that. Simply because, this thing can flip around, the OH group. This whole molecule flips around, twirls. So PCC, I'm just redoing this one. Really spelling it out. Really, really spelling it out. And again, this is just a memorization. This is just a reaction. No mechanism here. This is just straight up oxidation. Fun stuff. And that was a primary alcohol for number 1. Now we're moving into the secondary alcohol. And how you tell is this carbon here is connected to 1, 2 carbons, so that's secondary. Back here, this carbon was attached to one other carbon, so that's primary, 1. This carbon that the alcohol is on is connected to 1, 2, so it's secondary. Let's do a little PCC. Weak oxidizer, meaning for up here, weak oxidizer means it only goes to the aldehyde. That's what weak oxidizer means. Jones, on the other hand, which we'll get to in a second, is a strong oxidizer. Strong oxidizers give you carboxylic acid. Weak oxidizers give you aldehyde. That's an important thing that I meant to say. Weak oxidizer yields aldehyde. Strong oxidizer yields carboxylic acid. Very, very important to note. So PCC, weak oxidizer, that means we would be going to an aldehyde, right? Except, we've got a carbon here and a carbon there, so we're actually going to form the ketone. So that's straight up right there. Got your ketone. Number 3, you have Jones. So this is a strong oxidizer, so it would normally take a primary alcohol to a carboxylic acid. However, we have a secondary alcohol, and if there's no way to make a carboxylic acid, so we just make the ketone. Because if you try to make a carboxylic acid, if you did this would be a humongous mistake. Huge. massive mistake. Simply terrible mistake to make. Because when you do this, you're losing a carbon from here to there. This carbon is now gone. You're connected to an OH, which means that that carbon's not there. It's not represented. It's completely wrong. So don't feel bad if you made that mistake. Just understand early on that this is what you gotta do. Number 4. So we run into our primary alcohol now. This carbon is connected to one other one. So our primary. We're Jonesing. So what do? Jones is a strong oxidizer. We go to carboxylic acid. All right, bingo. Simple as that. Let's go number 5. So what kind of alcohol is that? That's primary. Because this carbon that the alcohol is connected to is connected to one other carbon. So this one other carbon means, primary. So what I have written here is DMSO, oxyl chloride, step 1, and then step 2 is this thing. And this step here represents the SWERN oxidation. Both of these steps, similar to how the Friedel-Crafts acylation ran in 2 steps with like step 1 and 2. Step 2 was water. Step 1 was like the acid halide and then the AlCl3. SWERN oxidation is similar in that it runs in 2 steps. The DMSO oxyl chloride and then this thing. And what this effectively does, it's a weak oxidizer, which means it basically will just take this to an aldehyde. If it was strong, it would go to the carboxylic acid, but that's not what we're doing. Because the SWERN oxidation, you must memorize that it's a weak oxidizer. I'm not going through this mech because I haven't seen it on any exams in the past 10 years. But I would still learn it before the test if you have time. Now let me make a side note. All right, I'm gonna do a side note. DMSO is this. Okay, you have an S, double bond O, methyl groups. Okay, oxyl chloride. That's what oxyl chloride looks like. So you could see it. You could see either one in the reagents for the reaction section. So be on the lookout. So let's look at number 6 again. I'm rewriting it because I can. So like I said, SWERN oxidation runs in 2 steps. If you see this step, you're always going to see this step after it, or else it's not the SWERN oxidation. And there's no other reaction that involves this DMSO oxyl chloride. So you're always going to see these paired up together. Anyway, weak oxidizer, you go to the ketone. And if you had a strong oxidizer, for example, so you had Jones, it would also go to the ketone because of reasons that I already mentioned. Other times, you're going to just see, so this is a primary alcohol. Primary because the carbon that the alcohol is attached to is connected to one other carbon, meaning it's primary. So the SWERN oxidation, well, this is, sometimes it'll just be written SWERN, and that actually means that's indicating the 2 other steps, because the whole thing's called the SWERN oxidation. So you're either going to see these 2 steps one after the other, or you're just going to see straight SWERN. That's kind of like the lazy way to do it. So you might see that, you might not, who knows. Probably going to see oxyl chloride DMSO. Once again, SWERN. Hoping that makes sense. Let's get into the good stuff. PCC. It's a weak oxidizer. You got your secondary alcohol. So then you just go to the ketone. That's all it does. Let's look at 13. I'm going to draw it up like this because it's the same thing. And I'm more comfortable drawing it up like that. So with Jones, you have a strong oxidizer. So right now we actually already have an aldehyde. So that's pretty neat. We go back to our little chart. We're already here. Jones is just going to drive it up to this. Because Jones, no matter what, Jones always yields the carboxylic acid. Because it's a strong oxidizer. Extremely strong. Now let's look at another one, 15. So you're given this one. And it's like, okay, this is a great problem. Because a lot of students might get confused here. So you got your thing. This is actually a tertiary alcohol. Because the carbon that the alcohol is attached to is connected to 1, 2, 3 other carbons. So it's actually a tertiary alcohol. You try to do a little PCC to that, and some students might think, okay, let me just do my double bond, and I'm good to go, right? No. You got this carbon, and it's got 1, 2, 3, 4, 5 bonds. That's a big no-no. Huge no-no. So this is no reaction. Because you don't even do that. That makes no sense. I just showed you just to kind of lead you down the rabbit hole and then, end it. So just end it right there. Don't even do that. Just, you see this? No reaction. However, you've got this one and you're trying to Jones it. What happens here though? So if you think about Jones, it's a strong oxidizer and you've got your tertiary alcohol. So what do you think will happen? Well, same story. You guessed it. Number 17 is showing SWERN. So you go from here to here, as I already showed earlier. And finally, number 18. This thing's kind of fun. I just made this problem up. So let's say we're gensing, okay? So we're on 18 now. So you have your primary alcohol, because the carbon that the alcohol is attached to is connected to one other carbon. You got your gens, so that's gonna oxidize this fully. By fully, I mean it's gonna oxidize it. Gens is a strong oxidizer. So it's gonna oxidize it all the way to the carboxylic acid. It makes sense. We have one carbon, we have our carbon there, and that carbon there is still right there. Simple as that. Now, we look down here, and we're like, okay, that's actually fully oxidized, because you can't put an OH over here. You can't like make a carboxylic acid. Otherwise you'd be losing that carbon. That doesn't make sense. So you leave that actually as a ketone. All right, so now it's time to look over at this functional group, which is the aldehyde. And like we showed in our steps, when we're doing a strong oxidation, this will go to the carboxylic acid. So that's our answer. So basically when you see PCC, it's gonna take you to an aldehyde, which, let me just show you an example of an aldehyde, or it'll take you to a ketone. Jones will either give you a ketone or a carboxylic acid. Let me just show the most simple examples real quick. So PCC, that's when it goes to the aldehyde because you have a primary alcohol. When you have a secondary alcohol, you do your PCC. That's when you would go to a ketone, all right? And then say you have your tertiary alcohol, PCC, no reaction. Contrast this with Jonesy. So this is a cool kind of chart that I'm just thinking up right now. Figured why not? I mean, this is actually kind of looking good so far. So you got your primary, this primary, secondary, tertiary, that's regarding the alcohol. So we gens, we do ketones. So let's try tertiary alcohol. You can't form 5 bonds to a carbon. If there's any questions, come ask. If you think there's any mistakes in today's worksheet, tell me. Because some of you guys are definitely smarter than me and you find my mistakes. So please don't be afraid to shout out.